प्यारे बच्चों, today we will discuss state transition matrix. State transition matrix is given by phi t equals e to the power 80. This is by definition. So this is the basic definition of state transition matrix. This is called state transition matrix because we can calculate other states by using this matrix if initial states are known. So that's why it is called state transition matrix. So now computation of the state transition matrix, we can use several methods. There are many methods for computation of state transition matrix, but two methods are very important and very simple methods are there. First method is by inverse Laplace method. We can use this method by using this one, state transition matrix, which is by definition phi t equals e to the power 80. We can calculate this inverse matrix first. If A is given, then we can calculate this part, and from that part, after taking Laplace inverse of that, we will get the state transition matrix. Another method is series expansion method. So this is the formula to obtain state transition matrix by using series expansion. So one by one we will discuss these two methods for computation of state transition matrix. So today we will take first method for computation of state transition matrix. So in first method we have to find out inverse of this Si minus A. So first we have to calculate inverse. In first method, so today we will discuss first method. By using this expression, we can take example. If A is given, suppose we are taking one example here. A is given matrix 0, 1, minus 8, minus 6. Calculate or compute state transition matrix by using Laplace inverse method. So for this method, first of all we will calculate inverse of this. So to calculate inverse, how can we define? Inverse of this is adjoint upon determinant. So first calculate this matrix Si minus. This matrix is difference of two matrix minus 8, that is 0, 1, minus 8, minus 6, that is AI, minus 1, 8 and s plus 6. After that we will calculate inverse. So now to find adjoint, now adjoint of this, we have to calculate this. So find matrix of cofactors. So matrix of cofactors, then transpose. So matrix of cofactors, after that you have to calculate this. I am here writing. Inverse is obtained as s plus 6, 1 minus 8 divided by determinant. So this is the determinant. We can calculate from that determinant of this as minus 1, 8, s plus 6. This is the determinant. After calculation, we will get this part s square 6s plus 8. So this is the inverse. Now to calculate STM, now you have to calculate this inverse. You can write it inverse. This is the, by separating terms, we will get 4 terms. So this is the inverse, and you have to take Laplace inverse of this. Laplace inverse of this is the Laplace inverse of this, and obviously this is the state transition matrix. When we will take the Laplace inverse of this is the state transition matrix. So to find out the Laplace inverse, we will find partial fractions. So to find this, suppose this term is a1 upon, you can factorize this, s square plus 6s plus 8 equals plus 4 into s plus 2. So you can write it, this is s plus 4 plus e2 upon s plus 2. After partial fraction, you can calculate a1 and a2. Similarly, for this other term, 1 upon s square plus 6s plus 8. Suppose this is a3 upon s plus 4 plus a4 upon s plus 2. Similarly for this term. So make partial fraction for all these individual terms. So we have 4 terms. For all these 4 terms, we have to find out partial fraction. So all coefficients can be calculated by using partial fraction method. So after calculation of coefficients, we can write this. So Laplace inverse of this term, Laplace inverse of this is the matrix. You can write all coefficients. So 2 upon s plus 2 minus 1 upon s plus 4 for other terms. So this is the first term. Similarly, second term here is half s plus 2 minus half s plus 4. So this is the second term. And for this third one, after partial fraction, this is minus 4 s plus 2 plus 4 s plus 4. So this is the complete third term, and for this last term here, minus 1 upon s plus 2 plus 2 upon s plus 4. So after partial fraction, we will get all these terms, and from here we can take Laplace inverse. Taking Laplace inverse, state transition matrix, which is written as S.T.M, is given by Laplace inverse of this. That is, now we can write this is 2e to the power minus 2t minus e to the power minus 4t. This is the first term after taking Laplace inverse. For second term, we have half e to the power minus 2t minus half e to the power minus 4t. This is the second term. For third term, minus 4 e to the power minus 2t plus 4 e to the power minus 4. This is the third term. And last one is minus e to the power minus 2t plus 2 e to the power minus 4. So this is the value of state transition matrix by using Laplace inverse method. So rule is very simple. Simply you have to find out this inverse, then take the Laplace inverse after taking the partial fraction. So main thing is partial fraction for this method. When we will get the proper partial fraction for the given term, then we can calculate Laplace inverse from this method. We can take one more example to understand the concept. Suppose now, example 2, take another example. Suppose A is given 0, 2, minus 2, minus 2. Find S.T.M using Laplace inverse. Method is simple. First write formula. Phi t is Laplace inverse of this Si minus A. Then calculate this Si minus A. For given A, this is the minus A. It is 0 to minus 2 minus 5. That is S minus 2 to S plus 5. So this is the, then find this inverse. Method is simple. First 1 upon determinant and after this I am directly writing inverse is then solve and check x square plus 5s plus 4. This is 2 upon s square plus 5s plus 4. This is minus 2 s square plus 5s plus 4, and this is s square plus 5s plus 4. Then, so first step is you have to calculate this inverse. So this term is inverse. This is the first step. After calculating this, you can calculate state transition matrix by taking the inverse. And to take the inverse, first we have to make the partial fraction of all these terms. Next step is state transition matrix STM given by Laplace inverse of this. That is, Laplace inverse of this means you can take the partial fraction, and after partial fraction you will get individual terms like take the partial fraction of this. Method is same. Suppose you are taking one term s plus 5 upon s square plus 5s plus 4. Then what is value? Suppose you are using two constants. Two factors are here, s plus 4 plus suppose b upon s plus 1. Then this is s plus 1 plus b s plus 4 upon this is the s square plus 5s plus 4. After comparison, you can write this is the a plus b s plus a plus 4b upon this. And after comparison, you will get a plus b equals 1 from first term and a plus 4b equals 5. This is the, and after solving you will get the constants. So this is the method to find the constants of partial fraction. So by using this method we can calculate all constants, and we can check here. So this we have, this is the 4 by 3 s plus 1 plus minus 1 by 3 s plus 4. This is the first term. So this is the first term. And second term, after taking the partial fraction, you will get 2 by 3 minus plus minus 2 by 3 upon s plus 4. Third term here for this one, for this part we will get two constants, and constants are minus 2 by 3 plus 2 by 3. So this is the third term for this one, and for this last term we have two parts, minus 1 by 3 and plus 4 by 3. So after partial fraction we will get all these constants, and taking the Laplace inverse we will get the final transition matrix, state transition matrix. So finally the state transition matrix is given by, take the Laplace inverse, we will get 4 by 3 e to the power minus t minus 1 by 3 minus 4t. This is the Laplace inverse of this first term. Similarly for all other terms, 2 by 3 e to the power minus t, then minus 2 by 3 e to the power minus 4t. This is for second term. For third one, minus 2 by 3 e to the power minus t plus 2 by 3 minus, and this is minus 1 by 3 e to the power minus t, and last one is 4 by 3 e to the power minus 2. So this is the method to find the state transition matrix by using Laplace inverse method. So this is all about the first method. So rule is simple. First find the inverse, then take the Laplace inverse of that matrix. Main thing is partial fraction of x. So after taking the partial fraction, you can easily get the Laplace inverse. So Laplace inverse of this is e to the power minus t. Laplace inverse of this is e to the power minus 4t. Similarly for all other terms. So this is all about first method. Means state transition matrix by using Laplace inverse method. You can take one example for assignment. For example, for assignment, then find STM using Laplace inverse. And answer of this problem is we will get 2 e to the power minus t minus e to the power minus 2t. This is the first term. E to the power minus t. This is the second term. Third one minus. So this is the answer. So method is simple. This is the A matrix. This is the A. Find this matrix, inverse of this, then take the Laplace of this. This is the STM. This is by definition given by phi t equals e to the power n. So this is all about first method. Okay, thank you. Next term we will discuss second method, that is by series expansion. Okay, thank you.